Today we are going to learn 13-6, solving quadratic equations by completing the square. The objectives of this lesson are as follows: to solve quadratic equations by completing the square, and to solve problems by identifying subgoals. Let's consider the following. In geography, the greatest flow of any river in the world is that of the Amazon, which discharges an average of 4.2 million cubic feet of water per second into the Atlantic Ocean. The rate at which water flows in the river varies depending on the distance from the shore. Suppose the Castillos have a home on the bank of the river that is 40 yards wide. The rate of the river is given by the equation y equals negative 0.01 x squared plus 0.4 x. Okay? Mr. and Mrs. Castillo do not want their children to wade in the water if the current is greater than 3 miles per hour. How many yards from shore the water flows at 3 miles per hour? We will solve this problem in example number 4. But if you recall from our previous lessons, okay, this is a good example of a quadratic equation. And in any quadratic equation, okay, the graph of a quadratic equation is what we call a parabola, such as the one that you have right there. Okay, and when a parabola opens downward is when you look at the coefficient of the quadratic term. If it's negative, it opens downward. If it's positive, it opens upward. Since the coefficient of our quadratic term is negative, okay, our parabola opens downward. Okay, we will use this example later on, example 4, to demonstrate what we have learned in terms of completing the square. You can solve some quadratic equations by taking the square root of each side. Let's consider example number 1. Solve x squared minus 6x plus 9 equals 7. Okay, if you notice, x squared minus 6x plus 9 is a perfect square trinomial. How do we know it's a perfect square trinomial? If you recall, a perfect square trinomial has the form of a squared plus 2ab plus b squared is equal to a plus b squared. Or if that's minus, all you need to do is change the addition to subtraction. So if you notice, x squared looks like a squared, 9 is actually 3 squared, and 2ab is 2 times x times 3, which gives us negative 6x. So that's how we know that it's a perfect square trinomial. Just a little recall there. Okay, and from there we factor it, and it becomes x minus 3 squared equals 7, since a perfect square trinomial. And to be able to solve for x, we need to get the square root of both sides. We do that, we end up with radical x minus 3 squared equals radical 7. And if you also recall, when you talk about the radical x squared is the absolute value of x. So radical x minus 3 squared, okay, now becomes absolute value of x minus 3 equals radical 7. We simply bring down radical 7. Okay, and from our past lessons, when you have the absolute value of x, okay, it branches out to either a negative x or a positive x. Okay, because the absolute value of x will be equal to x, but in this case x can be negative or x can be positive, right? So what happens after that? From there, notice that x minus 3 becomes plus or minus radical 7. Okay, and this now becomes easier to solve because you simply add 3 to both sides. So the result is 3 plus or minus radical 7. Okay, so So the solution is 3 plus radical 7 and 3 minus radical 7. Okay. What's interesting to note also is this. It's easy to do this. Okay. If it's easy to solve this equation if you know if it's a perfect square. Okay. That's a good thing about this equation. Okay. So to use the method in example 1, the quadratic expression on one side must be a perfect square. However, few quadratic expressions are perfect squares. To make any quadratic expression a perfect square, a method of completing the square may be used. So what is it saying? It's simply saying this. If on the left side, if the trinomial is not a perfect square, then we will make it a perfect square for us to be able to solve the quadratic equation. Okay? And let's move on. Consider the pattern for squaring a binomial such as x plus 5. If you have x plus 5 and you square x plus 5, okay, you end up with x squared plus 2 times 5x plus 5 squared. Okay, this again goes back to this particular rule right here. We have a squared plus 2ab, okay, plus b squared. That's what we followed in that particular case. So we have that, and simplify it further. We now have x squared plus 10x plus 25. Now the question is, how are we going to find 25 by just looking at 10 squared? So we want to find 25 by just looking at 10 squared. Let's analyze this problem. Consider the coefficient of 10x. Remember, the coefficient is the number before the variable. So the coefficient of 10x is 10. So what do we do with 10? We get half of 10, or multiply 10 by 1/2, so 10 over 2, and then we square it. Okay? After we square it, this is what's going to come out. It's going to come out as 5 squared. Okay? So now you have 5 squared, which is equal to 25. So by just looking at the middle term and getting its coefficient, you get half of the middle term, square it, and you get 25. Okay? Which brings us to this. To complete the square for a quadratic equation of the form of x squared plus bx, you can follow the following steps. Okay? First step in completing the square. Find 1/2 of b, which is the coefficient of x. That's what we did with 10. We found 1/2 of b. Okay? Remember, in any quadratic equation, it is always in the form of ax squared plus bx plus c equals y. Okay? That's a quadratic function. A quadratic equation will equate this to 0. There you go. Okay, so this is what we're looking at, the b. Find 1/2 of b, the coefficient of x. Okay, next step after that, square the result of step 1. That's what we did. After finding 1/2 of b, which is 10, we square it. And finally, the next step, add the result of step 2 to x squared plus bx, the original expression. So what are we going to do? We're going to add what we got in after getting the half of b and squaring it. We are going to add it to the rest of the expression right here. Okay, so how does this work? Let's consider this. Find the value of c that makes each trinomial a perfect square. You have x squared plus 20x plus c. You want to find c. You want to find c so that, okay, this whole trinomial becomes a perfect square. Okay, how do we do that? Let's find out. First step, find 1/2 of 20. 1/2 of 20 is 10. Okay, so that's done. Then square the result of step 1. So after getting 1/2 of 20, which is 10, square it, you get 100. Okay? And simply add it to x squared plus 20x. So it becomes x squared plus 20x plus 100. Okay? That now becomes a perfect square trinomial. Okay? And if you factor x squared plus 20x plus 100, since it's a perfect square trinomial, it becomes x plus 10 squared. If you notice, the 10 came from here, right here on step number 1. That's how you got 10. Okay? So after doing step number 1, you will use step number 1 to create your perfect square trinomial in factored form. Okay? Remember that, because once we solve equations using completing the square, okay, step number 1 becomes very important. Let's move on. Let's say you have x squared minus 15x plus c. Okay, again, go back. Let's go to step number 1. Find 1/2 of negative 15. 1/2 of negative 15 is negative 7.5. Okay? And after getting 1/2 of negative 15, we go to step number 2, which is to square the result of step number 1. So you get negative 7.5 squared, end up with 56.25, and simply add that to x squared minus 15x on step number 3. Okay? So step number 3 is simply adding the result from step number 2. So the value for c is 56.25. Therefore, you have a perfect square trinomial, x squared minus 15x plus 56.25. Okay? And again, remember what I just told you. Okay? Your negative 7.5 goes right there. Okay? And that's how you factor your perfect square trinomial by completing the square. Okay? So now let's solve x squared plus 8x minus 18 equals 0 by completing the square. We now have an equation, and we want to solve the equation by completing the square. Let's go to the first step. First step is simply rewriting it. X squared plus 8x minus 18 equals 0. Okay? We also notice that in this particular problem, okay, x squared plus 8x minus 18 is not a perfect square. Again, we go back to the 3 questions. Is the first term a square? The answer is yes, but we go to the second question. 18 is not a perfect square. At the same time, if you notice, there's a negative sign right there. And when you have a negative sign, okay, on that spot in a trinomial, that will never be a perfect square trinomial. The negative sign can be here, but it can never be right there. Okay, so this is not a perfect square trinomial. So what do we do to be able to solve this quadratic equation? By completing the square. Next step is we add 18 to both sides. Okay, so we add 18 to both sides. We now have x squared plus 8x equals 18. Okay, now what we can do next is we can complete this square. We can complete x squared plus 8x, okay, and make it into a perfect square trinomial. How do we do that? Okay, we get 1/2 of 8, which is 4, and we square it, which is 16. Again, the 3 steps. Get 1/2 of b, which is in this case 8, and then square it. So 1/2 of 8 is 4, square it becomes 16. And in commandment number 8 of our math, of the 10 commandments in math, whatever you add to one side, you need to add to the other side. And that's why we added 16 to the other side as well. Okay? So from there, we can factor x squared plus 8x plus 16 to become x plus 4 squared. Remember now that this is a perfect square trinomial. We just made it into a perfect square trinomial by completing the square. And in step number 1, 8 divided by 2, or 1/2 of 8, is 4. And that's what we used for the factored form of x squared plus 8x plus 16. And that's where we get 4 from, equals 34, which is simply 18 plus 16. Next step, okay, we get the square root of both sides. You now have x plus 4 equals plus or minus radical 34. Okay, going back, this step has been, there are a few steps that have been, that was not used anymore. Well, it was used, but they didn't show how they got to that step. You got the square root first, okay? They got the square root, they got the square root, okay? And then after that, after getting the square root, okay, of both sides, what did they do? Okay, they got the absolute value. So from after getting the square root of both sides, you have absolute value of x plus 4, okay, equals 34. And from there, this is what you got right here. From that step, you got there. Okay? And moving on, solve for x, subtract 4 to both sides, you end up with negative 4 plus or minus radical 34. So the value of x is negative 4 plus radical 34, or x equals negative 4 minus radical 34. So that becomes the solution set of our problem. Okay, negative 4 plus radical 34 and negative 4 minus radical 34. Okay, so from the method for solving quadratic equations cannot be used unless a coefficient of the first term is 1. Remember that. Okay, to solve a quadratic equation in which a leading coefficient is not 1, we need to divide each term by the coefficient. So again, in recap, for you to be able to use completing the square as a method for solving a quadratic equation, you need to make sure that the coefficient of your quadratic term, or your x squared or y squared, your x squared, is equal to 1. If not, you need to divide each term by the coefficient. Okay, let's look at this example and go back to the beginning of the lesson. Okay, how far from the shore will the rate of the current be in 3 miles per hour? If you look at this quadratic function right here, quadratic function has a coefficient of negative 0.01 x squared for the quadratic term. So that means you cannot use the completing the square method if this remains negative 0.01 x squared. So in order to get rid of negative 0.01, you need to divide each term by the coefficient. And this is what happens next. Okay, you substitute the value of 3 since the rate is 3 miles per hour. Now we have a quadratic equation. Okay, and then we divide all the terms by negative 0.01. When you divide all the terms by negative 0.01, you end up with negative 300, end up with x squared, negative 40x. Now you have a coefficient 1 on the quadratic term. That means you can use completing the square. Okay, well, before we go there, this is it. So what do? We get 1/2 of negative 40, square it, you get 400. Therefore, you add 400 to both sides. Okay, using the 3-step method of completing the square. We know that 1/2 of negative 40 is 20, and that's what we use to factor x squared minus 40x plus 400. Okay, and negative 300 plus 400 gives you 100. And then we square both sides, or we get the radical, the square root of both sides, end up with x equals 20 equals plus or minus 10. Again, remember the steps that were skipped here is that radical, okay, when you get radical, x minus 20 squared, okay, you end up with absolute value of x minus 20. And in order to get the absolute value of x minus 20 equals 10, you need to add the plus or minus sign. So those are the two steps that were skipped in that particular example. Okay, and finally from there, we now have x is equal to 10 plus or minus, or 20 plus or minus 10. Okay, the value of x, which gives us the solutions are 30 and 10. Thus, the children should not be allowed to wade more than 10 yards from the shore. Between 10 and 30 yards from the shore, the water is flowing too fast. Okay, and that's how you arrive at that answer using completing the square. Sometimes finding a solution to a problem requires several steps. An important strategy for solving such problems is to identify subgoals. This strategy involves taking steps that will either produce part of a solution or make a problem easier to solve. So, look at example number 5. Let's show how to derive the quadratic formula for solving the equation. Remember, quadratic equation is ax squared plus bx plus c equals 0. That is our quadratic equation. And if you notice, there are no values to that variable. So this is what we're faced with. The first subgoal is to choose a method for solving the equations. Since the coefficients are variables, we cannot solve by graphing. It is possible, however, to solve for x by completing the square. So let's try to do that. And from there, we go to our second subgoal, is to complete the square to find the value of x. Okay? And then here, we have here, down here, since the coefficient is not equal to 1, okay, we know this because it's a. If it's 1, then there won't be any variable before x squared. We need to divide the entire equation by a. So we divide everything by a. Okay? And then, to be able to complete the square, we subtract CA to both sides of the equation. Okay, and you have x squared plus b over ax equals c over a. And from there, okay, we complete the square. We get 1/2 of b over a, which is 2 over a. Square it becomes b squared all over 4a squared. And that's what we got. You add it to both sides of the equation. Okay, and then using completing the square, we now have x plus 2 over a. Again, 2 over a comes from b over 2 over a comes from here, and that's what you are going to use. Okay, that's what you're going to use to complete our square right there. Okay, jump from that point. Okay, we factor x squared plus b over a, x plus b squared all over 4a. That is a perfect square trinomial. Okay, and we get the radical sign, or we get a radical of both sides. I'm sorry, not that one. But from here and here, get the radical of both sides. Okay, you end up with x plus b over 2a equals plus or minus b squared minus 4ac all over 2a. Why did this become 2a? Because radical 2a squared, 4a squared is nothing more than 2a. That's how we got that value. Okay, and from there, okay, you simply subtract negative b over 2a to both sides. Okay, and then you simplify, you end up with negative b plus or minus radical b squared minus 4ac all over 2a. And this is how the quadratic formula was derived. It's out of completing the square. Okay? And that's it. After this, in your notebook, no more than a page, write or type a summary of what you've learned responding to the objective, and write a question you might want and ask about this lesson for the following day. Thank you.